इस पे गायब हो गया।
शोस लिंक पे
हम लोग दिए थे लिंक उसको, बट ओके
हाँ, इस पे भी गायब हो
हम
गया।
लोग जो लिंक दिए थे वो दूसरा दिए थे ना।
शोस लिंक पे
हम लोग दिए थे लिंक उसको, बट ओके
हाँ, इस पे भी गायब हो
हम
गया।
लोग जो लिंक दिए थे वो दूसरा दिए थे ना।
शोस लिंक पे
हम लोग दिए थे लिंक उसको, बट ओके
हाँ, इस पे भी गायब हो
हम
गया।
लोग जो लिंक दिए थे वो दूसरा दिए थे ना।
शोस लिंक पे
हम लोग दिए थे लिंक उसको, बट ओके
हाँ, इस पे भी गायब हो गया।
अच्छा
ओके,
लाइव तो आ गया। हाँ लाइव आ गया। इस पर भी दिखा रहा है।
फाइन।
यूट्यूब पर भी आ रहा है, बढ़िया अच्छा। अच्छा
Is it audible or not?
हाँ बिल्कुल बिल्कुल ऑडिबल हूँ। अच्छा ये दिखा रहा है ऑर्गेनाइजर स्पीकर, वेरी नाइस।
Okay, fine.
वेरी गुड।
Can we start now?
No, 4 what was the starting time? 3 p.m. right?
Yes.
Yeah. Yes, you can start.
So welcome
Just
everyone.
say, just check it. How many people have joined?
3 people are currently joined.
So 1 or 2 minutes we'll wait till some more joins, and then we can start it.
Okay, fine.
Yeah. So that some more participants will be there.
This time we have changed the interface.
Yeah.
Is that looking good?
So based on yes, so based on the feedback of the participants, now we can.
You are not audible.
Our speaker. So yeah, so today's talk it is on cyclic analysis using Seismostruct, and this session will be delivered by Professor G. Ahmad. He is currently associate professor at University of Chicago, Chile. Even later also, if you have any doubt, you can contact him for getting more clarity. So over to you, Ahmed, to take the session.
Thank you. Thank you, everybody. So today I'm going to present about how to do cyclic analysis. So let's go there. So first of all, I want to thank Mr. Sonu Kumar sir for giving the opportunity. And today I'm going to present how to do the cyclic analysis. Okay. In lab, we do the cyclic analysis. After doing the cyclic analysis, we have to verify it. So we can verify. For verifying it, we have to go the here. This is Seismostruct. So we are going to do the analysis, that is cyclic analysis using Seismostruct. So let me tell you how to do the cyclic analysis. So before doing the cyclic analysis, we have to model the structures. So today we are going to model the structure. This is the structure we are going to model. If you see here, this is around 4.2 meter length beam is there, and column length is 2.3 meter. Here also column length is 2.3 meters. So, and that UDL is applying on the top of the beam is 6.25 kilometer. So this is the problem we are going to solve in the Seismostruct. So let's see how we do the analysis. So before going to the, here you can do different kind of analysis like model analysis, static analysis, push-over analysis, time history analysis, dynamic analysis, incremental analysis. So there are different kind of analysis you can do. So today we are going to do cyclic analysis. So for doing the cyclic time history analysis. So after choosing the cyclic time history analysis, we have to go for the materials. So we have materials. If I show you here, we have FC is 37.56 megapascal and Fy equal to 604 megapascal. So we are going to use this FC and Fy for current model. So here is frequency material. So we have to define the material. For defining the material, we have to go new materials. So we have material and materials now. Here we can go whatever the materials we have to put, like concrete or steel, whatever is there, we can pick from here. So in this case, I have taken concrete materials. If you see the concrete materials, here there are different kind of models are there. For this case, we have chosen Mander confined model. So this is a Mander confined model. So this is Mander confined model we have selected. And based on the Mander confined models, we have given the compressive strength value. So let me show you once again. Compressive strength we have given that in kilopascals, 57.56 kilopascal. Same way we have given the tensile strength on model, and we have provided this strain at that is 0.002. After giving this concrete property, we have to go for the G property. Let's see that now we are giving for the G. Am I audible? So yeah. So still we have to select different kind of reference model for so based on the different models, whatever we could select, we have to get. We can give also integration material also. But in this case, I'm going to define management into models. So in this models, we have given this model surface simplicity, yield strength, and these are the parameters for defining these curvatures. We have to modify parameter going to a cyclic curve, that is hysteresis curve of structure. After defining the materials, we have to go for the section. So here in this case, our structure having 310 mm diameter. 310 mm diameter I have defined here, and there two longitudinal bar. That is longitudinal bar and steel bars are there. Cover thickness is there. 20 mm cover thickness is there. If we go for the reinforcement, so I'll show you the reinforcement is pattern. Here you can see the TMF cover spacing. If we see about this transverse reinforcement, here transverse reinforcement is 8 mm with 100 mm spacing.
Yeah, you can resume the session. Yes, yes, it is audible. You can resume the session.
Is that live streaming?
Yeah. Yes, yes, it is. It is coming.
Okay, fine. ओके सो व्हाट हम लोग क्या कर लेते हैं, हमें क्या करना होगा डिस्प्लेसमेंट कंट्रोल लोड असाइन करना होगा। सो डिस्प्लेसमेंट कंट्रोल लोड हमें कहाँ असाइन करना होगा, तो अगर हम एन1 से और एन4 के हम डिस्प्लेसमेंट कंट्रोल असाइन कर सकते हैं। ये कौन सा लोड होगा, ये होगा स्टैटिक टाइम स्टेट एनालिसिस। स्टैटिक टाइम स्टेट एनालिसिस लाइक हमने डिफाइन किया था डिस्प्लेसमेंट कंट्रोल, तो ये यही लोड था जो अभी मैंने दिखाया था अभी आप लोगों को, ये लोड है। तो ये लोड हमें असाइन करना होगा। इसमें क्या होगा, हमने इनिशियली जीरो दिया, फिर जीरो से हमने क्या किया, इनिशियल डिस्प्लेसमेंट टू, फिर जीरो, फिर -2, फिर जीरो, फिर टू, फिर जीरो, -2। इस हिसाब से हम लोग क्या कर दिए, बढ़ाते चलेगा और हम लोग वहां पे जा रहे हैं 80 mm डिस्प्लेसमेंट है। तो ये हम यहाँ असाइन कर रहे हैं। चलिए अब बताते हैं हम लोग क्या करना होगा मुझे। तो यहाँ जैसे ही हम क्या करेंगे, लोड डिफाइन करेंगे। तो लोड डिफाइन करने के लिए सिंपल जाना है लोड पे, सॉरी यहाँ हम लोग चल रहे थे, सिंपल जाना है ऐड पे। और ऐड पे जाने के बाद हमें किस नोड पे डिफाइन करना है, तो हमें डिफाइन करना है एन1 नोड पे। किस डायरेक्शन में डिफाइन करना है, तो डायरेक्शन आपको मैं ये देना होगा। तो यह कुछ भी डायरेक्शन, तो एक्चुअली समथिंग लाइक डायरेक्शन में यहाँ भी देना होगा, तो वो हम देख सकते हैं। इस केस में अगर देखें तो हमारे पास क्या है, एक्स डायरेक्शन लाइक इनसाइड एक्स डायरेक्शन होगा, वाई डायरेक्शन देख रहे हैं आप ग्रीन कलर, और जेड डायरेक्शन। हमें लोड असाइन करना होगा किधर, एक्स डायरेक्शन की तरफ। सो व्हाट वी हैव टू डू, फर्स्ट ऑफ ऑल वी हैव टू assign the load. So how we will assign the load, just go to the static time state load. There we are okay, first we'll say, first go to the plan, and here we have to go to the static time history load. So this is the load we have given, and then our node is n1 node, so we are going to define at n1, हम n1 पे डिफाइन कर रहे हैं। आफ्टर दैट हमें क्या करना होगा, हमें डायरेक्शन चूज करना होगा। क्या करना होगा, डायरेक्शन चूज करना होगा। किस डायरेक्शन में देना है, चल डायरेक्शन। आफ्टर दैट या उसके बाद हमें क्या होगा, हमें देना होगा टाइप, कौन सा टाइप तक। मैंने बताया था कि जो हमारा जो नोड है ये है हमारा डिस्प्लेसमेंट कंट्रोल नोड, क्योंकि जब हम साइक्लिक एनालिसिस कर रहे हैं यहाँ पे, तो हम डिस्प्लेसमेंट कंट्रोल दे रहे थे। लेकिन हम क्या करते हैं, इनिशियल डिस्प्लेसमेंट 2 mm दिया था, फिर 0 दिया था, -2, फिर 0, फिर +2, 0, -2, इस टाइप से हम लोगों ने लोड डिफाइन किया था यहाँ। तो यहाँ भी हम क्या करेंगे, यहाँ पे हमारा जो लोड होगा वो होगा डिस्प्लेसमेंट कंट्रोल। तो हम टाइप में जाएंगे डिस्प्लेसमेंट कंट्रोल, giving the displacement control. यहाँ है curve multiplier. Yeah, that we have to take. Okay, just I will show one more thing here. If you go here, time history curve. in the time history curve हमने क्या किया था कि हमने दिया था 2, -2, 2, -2 ये दिया था। इसका मतलब क्या है, हमारा जो डायमेंशन है, ये हमारा डायमेंशन जो यहाँ सेट है, वो है यहाँ देख सकते हैं, हमारा जो डायमेंशन है वो है मीटर में। इसका क्या हो गया कि जो इनिशियल डिस्प्लेसमेंट मुझे काट मिला मीटर में, तो बट हम तो डिस्प्लेसमेंट देना है हमें क्या, mm में, बिकॉज मीटर वी कैन नॉट असाइन दैट मच डिस्प्लेसमेंट। सो व्हाट हैज नॉट टू हियर, सो लेकिन हमने तो कर्व में तो दे दिया है 2 मीटर, -2 मीटर, 2 मीटर, तो दैट इज नॉट गोइंग टू यूजफुल हियर। सो व्हाट वी हैव टू डू हियर, here we have to just reduce the load, means reduce the displacement. So how we will reduce? So divide by 1000. If we are going to divide by 1000, then it will automatically scale down the uh, time history curve. So yeah, here we are saying go to the time history and what diaxle x, then displacement control curve multiplier will be 0.001. So this is going to be the curve multiplier, and then we have to define a what kind of curve. So हमने बोला हमने define किया displacement curve हमने दिया था यहाँ. So that question का we have to assign. So okay, let us choose the displacement curve. हमने क्या करते हैं displacement curve चुन लिया, ओके दबाना. तो फिर प्रेस करने के बाद क्या होगा, ये सेम टू सेम चीज आपके पास नजर आ रहा है. ठीक है. अब उसके बाद क्या करना है, ये तो हो गया, हमने एक लोड डिफाइन कर दिया ये वाला. ये कौन सा लोड है, साइक्लिक लोड है. उसके बाद हमें कौन सा लोड देना होगा, वो एक हमारे पास है यूटीएल लोड. यूटीएल लोड कहने का मतलब क्या हो गया, ये मेंबर लोड है. तो मेंबर लोड मतलब वो एलिमेंट लोड, यहाँ एलिमेंट लोड के नाम से जाना जाता है मेंबर लोड. तो हमें क्या करना होगा, एलिमेंट लोड डिफाइन करना होगा. कैसे डिफाइन करेंगे एलिमेंट, सिंपल आर पे जाना है एलिमेंट. तो हमने क्या बताया था कि ये n1 to n2 कौन सा एलिमेंट है, एलिमेंट 1 है. n2 to n3 that is going to element 2, and next element 3 is 4. So we have three elements. So क्या करेंगे हम, अलग अलग तीनों पे हम क्या करेंगे, लोड डिफाइन करेंगे. इज दैट परमानेंट लोड, यस इट इज परमानेंट लोड. किस डायरेक्शन में, वाई डायरेक्शन में. फोर्स, यस फोर्स. कर्व मल्टीप्लायर, how much load here. Now here we don't have to give the 1000 and 10,000. No, here we have to define the in kilonewton, that is force. No, so force we have to directly we have to give the value where, sorry, not by direction, in z direction. So what we have to do is, here we have to define in a z direction. How we have to define? So here we have to give negative z direction. So negative z direction is referred to gravity direction. So the value will be in minus. So minus 6.25 kilometer. So this is going to be our load. It is already in kilometer. So it's all. Now place OK. After pressing OK, this how we can assign the load in element 1, element 2, element 3. So up to here, any doubt? Let me take that out. After that, we'll move forward.
Yeah, some dots may be there. It may be posted in YouTube channel or other places. Just check it there.
Is there any doubt? Sonu sir?
Yeah, one person has posted on YouTube channel the parameter of the column section not so in the video. So I think he may not be able to see the
Okay.
parameters of column section that time. Yeah, yeah. No other questions are there.
So we have to go for the
Yeah, you continue the session.
fine. So okay, then we have to go for the, yeah, after assigning this all those things. Now we need not do this all those this we don't have to do. Now we will go to processing. So press the processor and then run the analysis. Just running the analysis, simply just click on the run and yeah, okay, I will just show here. This is a real time history. You can see how this curve is going to run. So this how it is going to run. So if you see here, this is taking me time, little bit time. So what we have to do, we have to just make it faster. For making the faster, here they are given. Do not see the detailed analysis information. If you don't want to see the different time steps, so just we will check this and see the only essential information. We don't want to see the graphical interface. We just close this also. After closing this, it will work fast. If you have further doubt, you can message me on Instagram or Facebook page. I'll try to solve your problem. अगर किसी को पूछना होगा कोई डाउट तो इंस्टाग्राम पे या फिर फेसबुक पे आप पूछ सकते हैं. Still running. So now it's going to finish. Let me show you. So after finishing this, we'll go to the post processing. Yeah. Okay. So this is the post processing. Now, if I want to show you how this curve had comes. So okay, let's see here. Uh, See how this structure is moving. Okay, I will show you the larger displacement. Okay, at the last point I will show you the larger displacement. देखो लास्ट में किस टाइप से ये स्ट्रक्चर को हम पुश एंड पुल कर रहे हैं. तो यहाँ देख सकते हैं कि हमारा जो analysis here. You have some correctly run कर Now we'll go for the output step. This is the some output step you can see here. Then we will go for the deformation. Already I have shown you convergence, which we have to see whether it is convergent or not. Yeah, everything has been convergent. So means result is perfect. Now we'll go with action effect diagram. This is just action effect diagram is just like a moment. Uh, Bending moment and shear force diagram you have to see here. So this is the moment and if you want to see this is information, dimension, shear force, two dimension, shear force. So all those are bending moment and shear force diagram. So this how we can see. For each time step we can see the bending moment and shear force. This time step. So every time steps how this bending moment and shear force is going to change. This also we can see. उसके बाद क्या करना होगा ओके बट हमें अभी तो हमें 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 क्या चाहिए हमें चाहिए साइक्लिक कर्व चाहिए तो उसके लिए क्या करना पड़ेगा हम चलेंगे ग्लोबल रिस्पांस पैरामीटर सो वी हैव टू गो फॉर द global response parameter now here you can see displacement this is the structural displacement and you can see here maximum minimum whatever you can see each node you can see this is the node 1 how this node 1 has been so whatever displacement we have given see node 1 is behaving like same displacement even if you see the node 2 also will be like same node 3 will be also like same so that means if node 1 node 2 and node 3 like behaving as a master nodes so same deformation we can see from node 1 node 2 node 3 all nodes we can see the same deformation okay let's go okay, let's go to the hysteresis curve. Static curve, what we have to see static curve. Uh, this is with respect to node 1. We have to see with respect to node 1. Just refresh it and you will see here. So this are the we can get the static curve. Okay. Suppose in case suppose if you see here this is the curvature of this curve. If it is not then I told you earlier, what we can do, we can just increase the time steps. How we increase the time already? Like 10,000, we have defined this here. We can increase to 20,000. It is not smooth. Or if suppose this curvature is also not matching with the your result, so what we have to do? We have to look for the models. What models we have taken here is a still model. So we have to look for the still model, and there we have transition graph modified something like here. Just modify the values uh, based on the model, like what models we are giving, and what are the requirement, whatever the other information we have. Based on that, you can just modify the value, and you can get the correct result. Okay, but then now we are planning to check this result. I want to match this result with experimental result. So okay, let's go and see the how experimental result is matching or not. Okay. So yeah, I'll show you the here. Okay, I'll show you here. This is the curve. Now you can see here, this curve is a lateral force upon lateral displacement. This one is matching. Not fully matched, but obviously it won't match fully. So this is how matching. So this is your perfect analysis. Now you can do the second analysis like in this way. Okay, thank you. Guru sir.
Yeah, I think there is no more question. So we can close today's session. So I think it was very informative for the scholars who just wants to like start their research work on this topic yesterday. And those who has some further doubts, they can write to us on any of the place, either in YouTube channel or on Facebook or Insta, any places. You have any queries, just reach out to us. We'll clarify them. Okay.